Alright, in this video we're going to be talking about 2.5, which is factoring. Factoring is a method of getting a polynomial like this right here into factored form, taking it from standard to factored. And again, like we talked about in 2.4, factored form helps us find the solutions to the equations by using the zero product property, okay? So we want to get from standard form to factored form. And last time we talked about finding the greatest common factor in order to get into factored form. However, your polynomials won't always be that easy to factor. So this is going to be a little bit different in the sense that this is a different form. So right here we have x squared plus bx plus c. B and c are numbers, okay? And they're very important numbers. They help us know how we can factor. So if we want to take a polynomial in standard form and get it to a polynomial in factored form, this is what it would look like, okay? So if these two numbers right here, p and q, if we add them together to get b, and if they also multiply to be c, so again these numbers right here, then that means these are our factors right here. So let me show you an easy way how to do this. So here's an example of x squared plus 6x plus 5. First identify what b and c are. So b is equal to 6. That's this number right here. It's the number in front of your x variable. And then c is the number all by itself. So c is equal to 5. So if we take 5, what we want to do is find numbers that multiply to be 5s. Okay, so that would be 1 and 5. 1 times 5 multiply to be 5, right? These two numbers also have to add to be 6. And they do in this case. So 5 plus 1 is equal to 6. 5 times 1 is equal to 5. So note here that these two numbers add to be 6 times to be 5. This is the b value, right? This is the b value, this is the c value. So that means 5 and 1, these two values right here are the factors. So x squared plus 6x plus 5 is equal to x plus 5 and x plus 1. These numbers right here that we found. Okay? Let's just do a lot of practice problems in order to get this down. So for 4 through 6, it just says factor the polynomial. So again, first identify b and c. So in this case, b is equal to d, c is equal to 8. Now take 8, which is the c value, find the factors of 8. So that's going to be 1 and 8, 2 and 4. Alright? Now, we know that these pairs of numbers multiply to be what c is, but do any of them add to be 6, which is what b is? And that would be these pair right here. So 2 plus 4 is equal to 6. So while 2 times by 4 is equal to 8, 2 plus 4 is equal to 6. So then the factors are d plus 2 and d plus 4. Okay? So we just rewrote this in factored form. So for this equation number 5, b is equal to 11, c is equal to 10. So take 10, list the factors of 10, which would be 1 times 10, 2 times 5. Now look at these two pairs that you have right here. Do any of them add to be 11? The answer is yes. that would have to be 1 and 10. 1 plus 10 is equal to 11. So then the factors are s plus 1 and s plus 10. For 6, b is equal to 10, c is equal to 9. So take 9, that's going to be 1 times 9. That's going to be 3 times 3. Those are the factors of 9. Do any of these add to be 10? 1 plus 9 is equal to 10. So that means u plus 1, u plus 9 is the is factored form of these polynomial equations. Okay? So it's not always going to be the case right here where everything's positive. Okay? Note that here, that these numbers right here, this is both being added together. Okay? And that's because our c is positive. Down here though, what happens when c is negative? So like in this case right here, well, you still follow the same rules. So if we have x squared minus 4x minus 5, where b is equal to negative 4, c is equal to negative 5, take negative 5 and let's list the factors right here. So let's think about it. If it multiplies to be negative 5, then it's either going to be negative 1 and positive 5, or 1 times by negative 5. Now do any of these, if it has to be multiplied, then it has to be negative 1 times by negative 5. No, I had it right before. Sorry about that. So it has to be either negative 1, positive 5, or 1 and negative 5. So do any of these add to be negative 4? So that would have to be this one right here. This right here, 5 and negative 1, so 5 minus 1 is equal to positive 4, but 1 minus 5 is equal to negative 4. So right there, 1 and negative 5, so our factors will have to be x minus 5 and x plus 1. So let's do more examples. So right here, b is equal to negative 1, that's the coefficient right there. C is equal to negative 56. So take negative 56 and list the factors. So that would have to be 1 and 56, except one of them would have to be negative. It would have to be 2 and 23. 2 and 28, sorry. So 2 and 28, where one of those is negative. It could be 4 and 14. Or it could be 7 and 8. Okay? Now think about it. One of these numbers has to be negative. One of the numbers in the pairs have to be negative, so that whenever you add and subtract them, you get negative 1. So I'm looking at this pair right here, because if I take negative 8 plus 7, that's going to be negative 1, but also negative 8 times 7 is equal to negative 56. So again, this is the b value, this is the c value. Okay, so these two numbers are the factors. So then our factors are z minus 8 and z plus 7. Now for number 11, b is equal to 2, c is equal to negative 24. Okay, take negative 24. And let's list the factors. That's going to be 1 and 24, 2 and 12, 3 and 8, 4, and 6. Now, which of these would add to be 2? That would have to be this pair right here. We would have to do positive 6 minus 4. So h plus 6, h minus 4. For 12, b is equal to negative 3, c is equal to negative 40. So negative 40, list the factors. So it's going to be 1 and 40, 2 and 20, 4 and 10, 5 and 8. Now can we take any of these pairs and combine them to be negative 3? That would be this pair right here. It would have to be negative 8 and positive 5. So factors are f minus 8 and f plus 5. Okay, now for 13, we have b. So the only difference here is that we're going to be solving the equation, because you see that we have an equation where the polynomial is equal to 0. So factor first, then solve the equation. So b is equal to negative 13, c is equal to 40. So if I take 40 and list the factors, it's 1 times 40, 2 times 20, 4 times 10, 5 times 8. Which of these can combine to be negative 13? So that would have to be here, where both it'd have to be negative 8 and minus 5. Negative 8 minus 5 is equal to negative 13, but negative 8 times by negative 5 gives us positive 40. So the factors are g minus 8 times by g minus 5. Okay, now we use the zero product property. So we take g minus 8, set it equal to 0, g minus 5 equal to 0. So we add 8 to both sides, so g equals 8, plus 5 plus 5, so g is equal to 5. So this is a solution to the equation. So we have to factor first, like this, and then find the solutions. This is what we did last time, using the zero product property, right? Okay. Let's do one more example. Let's go to 16. Right here we have x squared minus x equal to 30. Now we want this to be equal to 0, so subtract the 30 from both sides. So now I have x squared minus x minus 30 equals 0, where b is equal to negative 1, c is equal to negative 30. So take negative 30 and list the factors. That's 1, 30, 2, 15, 3, and 10, 5, and 6. So is there a pair of numbers that combine to be negative 1? That would have to be this pair, where it would be negative 6 and positive 5. So we have x minus 6 and x plus 5. And this is equal to 0. So take both factors, x minus 6 equal to 0, so plus 6. So x is equal to 6. Take the other factor, set it equal to 0, so minus 5. X is equal to negative 5. And that's the solution. X equals 6 and x equals negative 5. Okay, so that should just about do it. You can feel free to do these problems here, but that's what you should expect to see on your homework, just a bunch of factoring. If you have any questions, let me know in class, or you can come to my consultation. Thanks, guys.